Number 1, a circuit has a current of 8 plus 7i amps, and another circuit has a current of 5 minus 3i amps. What is the difference between the currents of these two circuits? So we're taking 8 plus 7i, and we're finding the difference, which means to subtract 5 minus 3i. So make sure that you remember that when we have to subtract, we distribute the negative sign through our parentheses so that we have 8 plus 7i minus 5 plus 3i. And from there we just have to add like terms. 8 minus 5 is 3. 7i plus 3i is 10i. So 3 plus 10i is our answer. And you might think that's a weird question, but imaginary numbers actually are really used with electric circuits and things like that, so go figure. Number 2, a manufacturer of lighting fixtures has daily production costs of C of x equals this stuff, where C is the total cost in dollars, and x is the number of units produced. Determine how many fixtures should be produced each day to yield a minimum cost. State the minimum cost. So what's happening, and you can put it in your calculator and graph it if you want to, is we've got a parabola that opens up, and if we can find the vertex of that parabola, which is the bottom point, that's going to tell us the number of fixtures will be x and the minimum cost will be y. So either we need to use our graphing calculator and find the minimum of this, which you get to doing second trace minimum, and it asks you for a like a left bound and a right bound and to guess, just like with zeros. Or if we remember our vertex formula, negative b over 2a, then these are backwards. C is actually first in this, b is the second thing, and a is this right here that's in front of our x squared. So we can actually plug this in and probably put this in the calculator. That's a positive 3.2 on top, divided by 0.8. If we multiply it out, and we get 4. So that's going to be how many fixtures we want to make, and then to figure out how much that would cost us, we have to plug that into our formula. C of 4, so 12.8 minus 3.2 times 4 plus 0.4 times 4 squared. Let me type that in real quick. And you get 6.4. And that's dollars because we're talking about costs. So that's how you do number 2. Number 3, now we talked about parent functions a while ago, and so you may not quite remember what was going on with them, but if we graph each of these, like if we graph y equals the square root of x in y1, and then we graph this other one in y2, here's what happens. Y1 starts here and goes up and to the right, and then when we graph y2, which we can do that on the same, like at the same time by putting it into y2, we'll see that our graph has moved left 3, down 5, and instead of it going up and to the right, it's actually going down and to the right like this. Like that should be kind of what your graph looks like when you graph on the calculator. And so what we're supposed to do is write out what just happened. So so we take y equals the square root of x and shift down, no comma there yet, down 5, left 3, and reflect over the x-axis. Okay, so there is a way, just looking at our equation, that we can tell this. Remember, if it's underneath our square root, then it does the opposite of what we think and affects x. So that's how we know it's going left 3. Outside makes it go up or down, so it goes down 5. The negative in front tells us that we have a reflection. But feel free to use your calculator to help you with that. Number 4, solve this equation by factoring. So if I want to factor and I have two terms like this, I want to see if there's anything in common that I can take out, which both of these have a 7 in. And so if I take the 7 and the n out of this, I'm still left with an n. If I take a 7 in out of this, well, I've taken out everything, but I have to put a +1 in because it's like a placeholder. Also, you can think of this whenever I take something out like I'm dividing by that. And so what is 7n divided by 7n? It's 1. Once we have it factored, we set each part equal to 0. And so if I divide both sides by 7 here, I get n equals 0. Here I subtract 1 and get n equals -1. So my two answers are 0 and -1. Completing the square. So we had kind of 5 steps that we have to go through. The first step is that we want to set up our equation. And so we want to take anything that doesn't have a variable with it and move it to the right side. So I'm going to subtract 56 over to this side. And when I write this out now, I want to put a blank where that was. 8 minus 56 gives me -48. Now, so that was my setup. That was my first step. My next step is to half and square. I take the number in front of my variable a, and I divide it by 2, so I half it, and then I square that number and get 49. That's the number I'm going to put in this blank, but make sure that you remember if I add it to one side, I have to also add it to the other side. So that's step 2. Step 3 is that we want to factor. So I want to say, what do I multiply together to get 7 that will add to get me 14? And it will be 7 and 7. And since they're the same, we can actually write this as a plus 7 squared. On the right side, -48 plus 49 is 1. That's our third step, was factoring. Now I want to square root both sides of my equation. And when I do that, I have to remember that if I square root in an equation, I have to put a plus or minus sign. And then I can find the square root of 1. It's 1. So I just have to finish it now. Subtract 7 from both sides. So a equals +1 minus 7 and -1 minus 7. So that means my two answers are -6 and -8. The next problem is completing the square again, so it should work out pretty similarly to what we just did. We got to set up. So -3 minus 29 is -33. We've got to figure out what to put in our blank. So we've got to do -12 divided by 2, which is -6. When we square it, we put it in parentheses and get +36. Make sure you add it to both sides. Factor b squared minus 12b plus 36. What multiplies to get 36? That adds to get -12, -6 and -6. -33 plus 36 is 3. Now I am ready to square root both sides. So I get b minus 6 equals plus or minus, because I took the square root. Square root of 3 can't be simplified, so I leave it as the square root of 3. And then I just need to add the 6 to both sides. And remember, you can't add a number and a square root together. You have to keep them separate. So this is 6 plus or minus the square root of 3. And that does have two answers, because that's really saying 6 plus the square root of 3 and 6 minus the square root of 3. Okay, so we've got solving by a whole bunch of different methods here, starting with taking square roots, which is really easy as long as you remember what it is you're supposed to do. We're going to try to get r by itself, which means I need to subtract 8 from both sides. So I have 5r squared equals negative 27 minus 8, which is negative 35. Then I would continue to solve for r, which means divide both sides by 5. Get r squared equals negative 7. And then I say, okay, I want to get the squared to go away, so I square root both sides. So r equals plus and minus, because I took a square root. Square root of negative 7 doesn't simplify, but I can take the negative out and make it be an I on the outside, so that my answer is I square roots of 7, plus or minus I square roots of 7. On 8, I need to divide both sides by 10. So at first it looks like this one is a little bit shorter. I square root both sides, and I get k equals, now this is where it ends up not quite being as short as you might think. I can simplify 27 because it's 3 and 9. 9 is 3 and 3. And so what happens if I just look at my bottom of my tree is that I have a pair of 3's and a 3 left over. So I square root of 27 simplifies into 3 square roots of 3, but that negative inside I'm going to pull out and I'm going to make it an I. So my answer here is plus and minus 3i square roots of 3. All right, 9 and 10 say to solve each equation by factoring. So that means that at some point here we want to have 2 sets of parentheses equals 0. And figure out what the factors are and all that. So the method I like to use for this, and I think most of you like to use, is called slide and divide. So we take the 6 and we slide it, so that's r squared minus 13r plus 42 equals 0. We factor that into 2 parentheses by saying what multiplies to get 42, that adds to get negative 13, which should be negative 6 and negative 7. And then we slid, so we've got to divide now, slide and divide. So the number we slid earlier, that's what we're going to divide by. So if it does divide, we go ahead and do that, like that's r minus 1. If it doesn't divide and we can't simplify it all, we move the number in front. And then that's us factoring to finish solving, because if it says solve in any of these instructions, it wants what does my variable equal. Well, I'm going to do r minus 1 equals 0 and 6r minus 7 equals 0, and I'm going to solve those equations so that r equals 1. And r equals 7/6. So r equals 1, r equals 7/6. And this next one's going to require us to do basically the same thing, okay, that the slide and divide thing. Or if you use the boxes to do it, that's fine also, or some other way, as long as you're getting the right answer. So what multiplies to get 10, that adds to get 11, 10 and 1. We're going to divide by the number that we slid at the beginning, which is 5. And so that gives us v plus 2 and 5v plus 1. And we're going to take each part and set it equal to 0. And get our 2 answers. So minus 2 on this one, v equals negative 2. Subtract 1. And divide by 5. Number 11. Solve each equation with the quadratic formula. So if you don't have it out in front of you, go and find the quadratic formula if you don't have it memorized. We need A, B, and C. A is 12, B is negative 3, C is negative 19. And we're just going to plug it into the quadratic formula. Negative B plus or minus the square root of b squared minus 4ac all over 2a. And then we want to simplify this a particular way. We want to do what's underneath the square root first without having the square root involved. I'm just going to type in just the way it looks, -3 in parentheses squared minus 4 times 12 times -19. And I get a 921. So my next step here, I'm going to have x equals a negative and a negative make a positive 3 out in front. And I'm going to have square root of 921 because I haven't taken the square root yet. 2 times 12 is 24. I'm going to check and see if I can take the square root of 921 because that's a big number. I don't know off the top of my head. Doesn't look like I can, so I need to check and see if I can simplify it. 921, if I factor tree it out, I can't divide it by 2 because it's not an even number, but if I divide it by 3, I get 307, and then I get kind of stuck because I don't know of anything that will divide into that. That's a pretty big number to try to divide a whole bunch of things into, so we're just going to say I can't simplify that square root and say that's x equals 3 plus or minus the square root of 921. So let's do another quadratic formula. A is 6, B is 11, C is -95. So x equals -b plus or minus square root of b squared minus 4ac all over 2a. So I want to figure out what's underneath my square root. 11 squared minus 4 times 6 times -95 is 2401, which is a big number. We're going to leave it as square root of 2401 right now, over 12. And again, like, I don't think that's square root, so I'm going to check and make sure. Oh, it does, 49. That's convenient. Square root of 2401 is 49. So we have -11 plus or minus 49 over 12. And so the way we work this out is this is two different things. We've got -11 plus 49 over 12, and we've got -11 minus 49 over 12. So just make sure if you do this in the calculator, you do the top first and then divide by the bottom, or set it up as a fraction or whatever. That should be 38 over 12, which simplifies to be 19 over 6. And this should be -60 divided by 12, which is -5. So our two answers should be 19 over 6, comma, -5. Now, this says solve each equation, but it doesn't specify how, and so I look at this and say, hey, if I don't have an x, then I can just, like an x term that doesn't have the square root, I can just add this 144 over and then take a square root. The other option that would be pretty easy is to factor into x plus 12, x minus 12. So x equals, make sure that since you square rooted, you need to put a plus or minus, so our answer is x equals plus or minus 12. And then 14, we need to pull out our calculator. We're approximating the zeros there to the nearest tenth, so we need to graph the function they gave us. So an n to y equals, you type x squared plus 2x minus 2. And then remember how we find zeros. We go to second trace and we pick 0. And then it asks us 3 questions. It asks us for a left bound, a right bound, and then it asks us to guess. So if I do that, like when I graphed it, I have this parabola here. Let's see, x and y-axis. So if I want to find this point here, I do, my left bound's going to be somewhere up here, my right bound's going to be somewhere down here, and then I guess in the middle, and I get negative 2.73. Well, it asked me to round to the nearest tenth, so I guess I don't need that 3. And then I do it again. I go to second trace, and I pick 0, and then now my left bound is going to be, because now I'm trying to find this point, so my left bound's going to be over here, my right bound will be here-ish, and then I have it guess, and so I'm getting 0.732, so that's just 0.7 if I round to the nearest tenth. So those are my 2 zeros. Now 15 through 20, I am trying to simplify things, and so what matters is, like here we're subtracting, so remember we've got to distribute that negative and then add like terms. So minus 2 minus 4i, I've got 5 minus 2, which is 3, and 5i minus 4i, which is 1i, or just I, so that's 3 plus I. But what mattered is that we're subtracting between them. Here I don't have anything in between my parentheses, so I'm multiplying, which means I need to FOIL. So first, 8 times 5 is 40. Outer, 8 times negative 5i is negative 40i. Inner, negative 3i times 5 is negative 15i. Last, negative 3i times negative 5i is positive 15i squared. And then remember that I squared is really a negative 1. And so what this does is it changes this from a plus 15 to a minus 15. And then we're ready to add like terms at this point. 40 minus 15 is 25. Negative 40i minus 15i is negative 55i. Now dividing is a little trickier. If there are 2 terms on the bottom, we change the sign of the middle term and multiply it on the top and the bottom, which on this particular problem means we're going to have to FOIL on the top and on the bottom. So on top, negative 9 times 5 is negative 45. Negative 9 times negative 10i is plus 90i. 3i times 5 is 15i. 3i times negative 10i is negative 30i squared over 5 times 5 is 25. 5 times negative 10i is negative 50i. 10i times 5 is plus 50i. 10i times negative 10i is negative 100i squared. So we've got to change our I squareds to i's. To negative 1s, sorry. And so that will change this to be a positive 30 and a positive 100. So on top, our like terms are negative 45 plus 30, which is negative 15. And then 90i plus 15i is 105i. On the bottom, the middle terms cancel, and I have 25 plus 100 because we multiply these together and it changes signs. So 25 plus 100 is 125. We split this up into negative 15 over 125 plus 105 over 125i, so that we can see if we can simplify, because I can take a 5 actually out of both fractions, so that this is negative 3 over 25 plus 105 divided by 5 is 21 over 25. Our answer will either look like that or it'll just be negative 3 plus 21i over 25. Might look like that instead. If it was multiple choice, which it may or may not be. So 18 has one term on the bottom, so all we have to do is multiply the top and the bottom by I. Now, if you accidentally forget that that's all you have to do, and you try to multiply it like by plus 5i, you'll still get, you'll still do what you need to do, but you'll end up having to like cancel stuff out at the end. So I want to distribute the I on top, 10i minus 4i squared. On bottom, negative 5i squared. I need to change my I squareds to negative 1s so that I have 10i plus 4 over a positive 5. And then either our answer would look like this, or it might be that we have to change it to 4/5 because I want the what doesn't have I to go first, plus 10i over 5, which 10i over 5 will actually simplify to 2i. So that might be what our answer looks like. On 19, it just wants me to simplify the square root. So I take the negative out, and that gives me I square roots of 75. But if I factor tree 75, I'll see that I have a pair of numbers, 5 and 5. And so I can take a 5 out. 3 gets left on the inside. So this is 5i square roots of 3. On 20, I'm going to do the same thing and simplify. The negative I'm going to move out. So this is negative 6i square roots of 72. I'm going to factor tree 72. So 8 and 9. 8 goes to 2 and 4. 4 goes to 2 and 2. 9 goes to 3 and 3. And remember, we only want to pay attention to the bottom leaves of our tree. So I have a pair of 2s and a pair of 3s. So those will both go on the outside, and on the inside I'm left with a 2 because I had 3 of them. Now I also have to remember to put this in front. Okay, negative 6i is in front. So I multiply what's on the outside of my square root. 6 times 2 times 3 gives me 36. It's negative, and there's an I, square roots of 2, like so. Explain where the solutions of a quadratic equation are found. Well, they're found where the graph crosses the x-axis. Or they're found at the x-intercepts or something like that. And then it says to state the solutions for this graph. There's a solution here and a solution here, 0 and 6. Remember, it's where it goes through the x-axis. Our vertex is the top of that parabola, but it doesn't want us to find that. So don't accidentally put that thinking that's the answer, because it's not. 22 asks us to write the equation of the parabola using the parent function y equals x squared. And so what's happening is y equals x squared, if you graph it, is a parabola that's got a vertex at 0, 0 and opens up. So we have reflected our graph, which means that we take y equals x squared, which we started out as, and we would change it to y equals negative x squared. Okay, because instead of it opening up, it's opening down. But also we moved our vertex to the left 5 and down 5. And so what happens is left 5 is on the inside of parentheses, and instead of it being a minus sign, it's the opposite, it's a plus sign. And then on the outside, our shift down goes minus 5. And so if you find this tricky, what you can do is you can try out different options. Like if you thought maybe it was a minus 5 on the inside, graph it on your calculator and see if it gives you a parabola that's moved the correct direction. And if it's not, then try something else. So, and our last section says choose whether you would prefer to solve by taking the square root, completing the square, or using the quadratic formula. It asks to state the method you choose and then solve the equation using that method. And actually, there's a fourth method not listed here called factoring. That's another option. So like on 23, like on any of these really, if you can factor, that's going to be the fastest thing. So look at this and say, can I multiply negative 24, something together to get negative 24 that adds to get negative 5? I can, because I can use negative 8 and positive 3. So the method I just used was factoring. So x minus 8 equals 0, x plus 3 equals 0, and I get x equals 8 and negative 3, because I add 8 over on this one, I subtract 3 on this one. So x equals 8 and negative 3. On 24, we could factor this, but I actually would use the square root method, partially because I'm just trying to show you some different methods, but also because all I've got to do here is add 1 to both sides and get a squared equals 1, square root, and I get a equals positive and negative 1, because the square root of 1 is 1. On 25, we can factor, but I would not want to ever try to complete the square on something that has a number in front of x squared, and factoring with the number in front of x squared can also be difficult, so you might just try using the quadratic formula. We can't use the square root method because of that x term in the middle. But if I quadratic formula this, it shouldn't be too bad. And then I'd also want to say what method, quadratic formula. Let's see, x equals a positive 9 plus or minus. Underneath my square root, I get 81 plus 40, which I don't know what that is, so I'm going to pull out my calculator. 81 minus 4 times 2 times negative 5 is 121. Okay, so that's good. Square root of 121 over 4 is 2 times 2 is 4. So I can take the square root of 121 and I get 11. And so I'm doing 9 plus 11 over 4 and 9 minus 11 over 4. So my answers are 20 over 4, which is 5, and negative 2 over 4, which is negative 1/2. This last one, this would be a good one to complete the square on. Because for one thing, we've already got this number on this side. And so we can just put our blank here, and now we're going to half and square the number in front of m, which gives us 4. So we add 4 to both sides. We can factor m squared plus 4m plus 4 into m squared, m plus 2 squared. Negative 3 plus 4 is 1. I can then square root both sides and get m plus 2 equals plus and minus 1. Subtract 2 so that m equals positive 1 minus 2 and negative 1 minus 2. So my answers are negative 1 and negative 3.